So we've talked about the transition probabilities, which describes the probability of the system changes from one state to the other state in one time step. Here we are going to talk about another type of probability, which is called the initial probability. So the initial probability simply means that the probability that the system at the beginning is at state I. It is denoted as QI as well. So because we have a lot of states in our system, so state 1, 2, 3 up to S, which means that we have Q1, Q2, Q3 up to QS. So this is called the initial probability distribution. So in other words, what is the probability that the system at the beginning of time is at state 1? What is the probability that the system at the beginning of time is at state 2? Up to what is the probability at the beginning of time the system is at state S? So Q1, Q2 up to QS, those are called the initial probabilities, and the Q shows the initial probability distribution. So this probability is called initial because we are talking about the beginning of time only, so we are only talking about time 0. And then you also should notice here that we don't talk about transitioning. It's just one point of time, just at point 0. It's not like the transition probability that shows probability of changing from this to that in one time step. No, initial probability is just one point of time, which is time 0. And then if we know this initial probability distribution, it may change the distribution after n steps. So because the transitioning that happens in those steps, the distribution will change as well. And then to find the new distribution, we may just compute Q times P to the power of n, which again, n is the number of steps that we're interested at. Let's see the next example to make this concept more concrete. So we're going back to the COLA example, which has this transition probability matrix P. But now we have an additional information saying that 60% of all people now drink Cola 1 and 40% now drink Cola 2. So you should notice here that it talks about now, so just time 0. And it doesn't talk about transitioning or changing, it's just talking about now. So this is a clue that this information is about the initial probability distribution. So which means that this information equals to saying that Q equals 0.60 and 0.40. So 0.60 means 60% is currently drinking Cola 1. 0.40 means that 40% of people now drink Cola 2. 3 purchases from now. So the question is 3 purchases from now, what fraction of all purchases will be drinking Cola 1? So in other words, it asks you after 3 purchases, how is this distribution look like? So same as before, when we talk about 3 purchases, means that first you need to compute P to the power of 3. So from the previous slide, we see that this is our P to the power of 3 matrix. So when you are asked about the distribution of purchasers, you simply need to do Q times P to the power of 3. So the Q is 0.6.4, and then P to the power of 3 is this matrix here. And then from the answer, you see that this 0.6438 is the fraction of all purchasers will be drinking Cola 1 3 purchases from now. So you see that the distribution changes from 0.6.4 to become like 60% and 35% after OR3 purchases. So here's a question to check your understanding. As usual, I will give you the answer after the pause of the video. So here's the question. The value 0.40 in the initial probability distribution Q means that 40% of cola to purchaser will buy cola to again. Is this statement true or false? The answer is false. Remember that Q here, it only talks about the distribution of customers at time 0. It does not say anything about future purchases. It just talks about the distribution of customer at this moment. Okay, so that's the end of this video. I hope you get the difference between transition probability and the initial probability, and how to compute this distribution after several steps.